Welcome to the section about waste and circularity, where we will be discussing various aspects of solid waste and its impact. We will explore the issues surrounding plastics, textiles, glass, metal, paper, and food waste. So let's dive right in. First of all, why are we talking about waste? Well, reducing waste and establishing circular economy systems are vital for several reasons, encompassing financial, environmental, and social elements. A study conducted by the Ellen MacArthur Foundation estimated that transitioning to a circular economy could generate economic benefits worth $1.8 trillion by 2030. Moreover, it could create up to 100,000 new jobs in the European Union alone. Secondly, from an environmental standpoint, waste reduction and circular economy practices help conserve natural resources. The United Nations Environment Programme reported that global resource extraction is expected to triple by 2050, with serious implications for the environment. Implementing circular economy principles can significantly reduce resource consumption and mitigate the negative impact associated with extraction and waste disposal. Circular economy systems also contribute to social well-being by promoting sustainable consumption and production patterns. They can enhance social equity and inclusiveness by creating job opportunities, supporting local communities, and reducing pollution-related health risks. A report by the World Economic Forum highlighted that circular economy strategies could deliver substantial social benefits, including poverty reduction and improve access to essential services. Let's look at the most famous waste, plastics. Plastics have become a significant concern globally due to their increasing production and long degradation time. It can take up to 1,000 years for plastic to degrade, leading to accumulation in landfills and oceans. However, plastics also have their advantages, such as durability and versatility. Plastic is also important in the medical and many other industries, since it is lightweight and in that sense can reduce the carbon footprint from transporting items packaged or made out of plastic instead of other heavier materials such as metal or glass. Nevertheless, our obsession with plastic, especially single-use ones, and its detrimental impact on human health and the ecosystem has made many countries start imposing bans on single-use plastics to combat the growing plastic waste problem. Interestingly, some jurisdictions are also banning alternatives to plastic. For instance, the European Union has restricted certain bioplastics and alternative materials due to insufficient testing in environmental conditions. Moreover, the plastics oftentimes behave in the same way as regular plastics, and our waste management systems are not ready to handle the different types effectively, further diluting efforts for better recycling. However, the innovation continues, and we are seeing plenty of new and potentially better materials emerging across the globe. So how about we replace plastic with glass? Glass is also problematic in terms of its environmental impact due to its low recycling rate and the depletion of sand. Although glass is infinitely recyclable, the recycling rate for glass is relatively low, with only around 33% of glass bottles being recycled globally. The remaining glass waste ends up in landfills, where it takes thousands of years to degrade. Moreover, the production of glass relies heavily on sand, which is becoming increasingly scarce. Sand is a vital component of concrete, glass, and other building materials, and its extraction has significant environmental impacts, including habitat destruction, soil erosion, and water pollution. The United Nations Environment Programme has warned that sand scarcity is a growing concern and estimated that sand depletion could reach 90% by 2100 if current trends continue. It is essential to improve glass recycling rates and explore alternative materials to reduce the reliance on sand in glass production, but glass recycling faces several challenges that hinder its effectiveness. First of all, contamination. Glass recycling can be compromised due to contamination from non-glass materials such as ceramics, metals, and plastics. Contaminated glass is difficult to recycle and may lead to lower quality recycled products. Secondly, color sorting. Glass comes in various colors, such as clear, green, and brown. Separating different color glass during the recycling process is essential for producing high-quality recycled glass. However, this sorting process can be complex and expensive. Another big issue is the energy-intensive process of glass recycling. While glass recycling saves energy compared to producing glass from raw materials, the recycling process itself requires significant energy inputs. So how about metal, you ask? Metal is a highly recyclable material and retains its properties even after multiple recycling cycles. Currently, it is the most recovered material from waste streams. However, it is crucial to recover precious metals from electronic devices, as their extraction has both environmental and social consequences. Some companies, like Apple, are already exploring ways to recover precious materials from electronic devices, reducing the need for mining and minimizing the environmental impact. Other light material is paper. However, the production of virgin paper involves tree cutting and land usage, contributing to deforestation. While paper is recyclable, there are limitations to its recyclability, especially with paper contaminated by food waste or other substances. Think pizza boxes, which are not recyclable due to the greasy stains and food residue. Finding more circular solutions to cut down on paper production is essential to protecting our forests and minimizing the waste problem. Another important waste to tackle is textile. Textile production has a significant impact across all environmental, social, and governance areas. One of the major concerns is water pollution caused by textile dyeing and finishing processes. Textiles are also notoriously difficult to recycle, resulting in vast amounts of textile waste ending up in landfills. According to the United States Environmental Protection Agency, approximately 11.3 million tons of textile waste are generated annually in the United States, with only 2.6 million tons being recycled, equating to a recycling rate of around 15%. The remaining 8.7 million tons of textile waste end up in landfills. Another problem with textiles is the material production. The production of cotton requires a significant amount of water. On average, it takes approximately 2,700 liters of water to produce a single cotton t-shirt. However, it's important to note that water usage can vary, depending on various factors, such as the location of cotton cultivation, irrigation methods, climate conditions, and farming practices. In water-scarce regions, or areas where cotton is grown using inefficient irrigation techniques, the water footprint of cotton production can be even higher. Another tricky material is polyester. This commonly used textile material is essentially pure plastic and sheds microplastics during washing. These microplastics find their way into waterways and can enter human and animal bloodstreams, posing potential health risks. We need improved textile waste management practices, increased recycling, and the adoption of circular economy principles, as well as innovation. Lots of companies are coming forward with innovative solutions, such as fabrics made out of bamboo, pineapple, or even CO2 and methane. Finally, let's look at food waste. Project Drawdown, an initiative focusing on comprehensive analysis of climate solutions, estimates that addressing food waste is one of the most effective ways to mitigate climate change. According to their research, reducing food waste ranks as the third most impactful solution out of 80 solutions considered. Food waste is indeed a critical issue, with significant environmental, social, and economic impacts. Globally, it is estimated that around 1/3 of all food produced for human consumption is wasted. This amounts to approximately 1.3 billion tons of food wasted each year. From an environmental perspective, food waste contributes to greenhouse gas emissions, particularly methane. When food waste ends up in landfills, it decomposes and produces methane gas, which is approximately 25 times more potent than carbon dioxide in terms of its global warming potential. This further exacerbates climate change and its associated impacts. The social implications of food waste are also significant. While millions of people suffer from hunger and malnutrition, a substantial amount of perfectly edible food goes to waste. Think about the ugly produce that is being discarded at farms because supermarkets and consumers would not buy it. In addition, food waste has economic consequences. The economic value of wasted food is estimated to be around 1 trillion annually. This includes not only the value of the food itself, but also the sources invested in its production, such as water, energy, and labor. By reducing food waste, economic savings can be achieved along the entire food supply chain. It is estimated that by 2050, implementing strategies to reduce food waste could prevent the emissions of 70.53 gigatons of CO2 equivalent. These strategies include improving post-harvest handling, storage, and infrastructure, as well as changing customer behavior and reducing food losses along the supply chain.